Just doing some settings. All right, so this is what we did in the last 4 lessons. We talked about sequences and series. So there's arithmetic sequence and arithmetic series. So these are all the formulas. Geometric sequence and series are given by these things, and there's also infinite geometric series. And so arithmetic sequence includes like 1, 3, 5, etc. These are going up by 2, so constant amount, and 1, 3, plus 1 plus 3 plus 5, etc. That's arithmetic series. So this one is sequence, this is series, okay? So this one is sum, that's why we use S, and this is just sequence of terms, so we use the letter T. Geometric sequence is like 1, 3, 9, 27. You multiply a term by the same amount, like 3, 3, 3, then you get a geometric sequence. If you add them all up, then you get geometric series. So there's no problem with that. And infinite geometric series is finite. So it sounds like an oxymoron. So infinite geometric series is finite, and it's given by this. If R is the common ratio, isn't it? So it's between 1 and -1. But we're not going to do any question on arithmetic sequence and series or geometric sequence series this time. Maybe we'll do it next week, okay? If time permits, then we'll go through this as well. But I'm going to go through this stuff, the quadratic equation. So there are basically 3 forms. So there's the general form, x-intercept form, and the y-intercept form. And how do you plot quadratic equation? You need 3 items. So if you have like a quadratic equation that goes kind of like this, obviously you have a vertex, you can have the x-intercepts, and you can find the y-intercept as well. So you need those 3 components, but you don't always need all of them. Okay, sometimes you're gonna see you will see cases where quadratic equation is sort of like that. So in that case, you don't have any x-intercept, of course. So that's the reason why I wrote find x-intercept if any. So in this case, you can find the y-intercept and the vertex there. Okay, and now the discriminant is this delta. So this is a Greek letter, capital delta in Greek, and that's read as discriminant, and that's b squared minus 4ac. And these b, a, c, these are from this form, general form. So these cannot really be found. Only a can be found. So this a is the same as this a and this a. They're all the same thing. But in this case, you cannot really see b or c. This is alpha, and this is beta. So they're different from a, b, c. Okay. And here's a h and k, which gives you the vertex, the coordinate of the vertex. So that here is h, k there. Hold on. Yep, okay. And if the delta is greater than 0, then you have 2 x-intercepts. If the delta is 0, you guys know this, it's you only get 1 intercept. And if delta is less than 0, then you just don't get any x-intercept like this one here. And we also talked about how to plot polynomials. So if you have a polynomial that is given by like p of x is given by like 3 x minus 2 square x plus 1. So how do you plot something like that? All that information is given here. Obviously you may have an expanded version of polynomial like 3x4 plus 4x3 plus 2x squared, etc., etc. And we talked about how to factorize this one from here to here using long division, of course, long division. And you can factorize, or we talked about synthetic division. So we'll get some chance to practice those in this tutorial again. So for something like that, if you have like x plus 1, see this is power of 1, right? So that means if you have this x-axis and y-axis, this one goes through -1, -1, and this one goes through 2. And overall, the whole thing is the order is 3. So it should look like that or like that. But you can see that when you expand all this out, you get something like 3x to the power of 3, blah, 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 right? So the orientation, whether it's going to go that way or that way, depends on the value of a. A is the coefficient of the leading term. So usually this one, all right? So if that's positive, then it's cubic, and because it's positive, it's going to go that way instead of that way, all right? So this is going to go through -1 and 2. However, because it's -1 and the x plus 1 to the power of 1, it's just going to pass through this. And because it's x minus 2 square, it's going to bounce off this one, all right? So we know that it's going to go up to infinity and -infinity. And it is going to just pass through this. And then it's going to bounce off that one. So all that information, all this technique can be found here. So if power of 1, then it just passes through. If it's square, then it bounces off, either like that or like this. If it's power of 3, then it passes through, but in a flat manner. It becomes flat at the x-intercept. All right, and this is for square. That's quadratic. This is upside down quadratic. This is cubic. This is quadtic. This is pentic. Also, we talked about factor theorem. So if you plug in some value into the polynomial and it becomes 0, that means x minus alpha is a factor. So we'll practice this one as well. So at the moment, it may not make any sense if you are new in this area, or if you found it difficult last time, you may also find that my explanation a bit too fast or not making any sense, but it will all make sense by the end of this lesson, okay? I'm pretty sure. So this is so if you plug in alpha into the polynomial, it becomes 0, then x minus alpha is a factor. So for example, if you have 2, if you plug in 2 into the polynomial and turns out to be 0, that means the remainder is 0. So this represents the remainder. And if you're wondering how that represents the remainder, you can watch my previous lecture, okay? So it's going to be all available. The recording will be available online. So if you plug in 2 there and it becomes 0, that means x plus 2, no, x minus 2, okay, is a factor. All right, if it's plus 2, then minus 2. If it's minus 2, then it's plus 2 here, okay? And the polynomial can be factorized into, in this case, of course, this is a factor, then the polynomial can be factorized into x minus 2 and some quotient. We call this guy quotient. So what is a quotient? So for example, we know that 18 is divisible by 2 and the quotient is 9. So in this case, we can write 18 as 2 times by 9. So if you divide polynomial, and if it's divisible by, for example, x minus alpha, then we get a quotient. So we can write the polynomial as a multiplication of this one and the quotient. So that's what I'm doing there, okay? Now, I told you that this represents a remainder. So if the remainder is 0, then of course it's a factor. In this case, 2 times by 9, then 18, and remainder is 0. So in this case as well, this times by this is the whole polynomial, and the remainder is 0. Okay? So remainder is 0, then it's a factor, of course. Just as this one is remainder 0, so that's a factor. Here, there's no remainder, so this is a factor. However, if you plug in something and it doesn't turn out to be 0, but it's something else, like constant or, I don't know, it could be like 2 or -1, whatever. If it's non-zero, then x minus alpha is obviously not a factor because there's a remainder, and r is a remainder. So in this case, the polynomial can be written as x minus alpha quotient, but there is a remainder, okay? So this is the summary of what we did last time. Okay, so we're going to try maybe 10 questions from quadratic and 10 questions on I forgot to summarize the graph translation, so we're going to go through that as well. Okay, so graph translation and dilation. So let's talk about that briefly as well. So if you have, for example, f of x, original function that whatever, and you may have a negative of f of x. You may have f of a negative x. So this is original. Negative f of x is the original. So let's say the original graph is this, which is x squared. Let me just give me a minute. Yeah. And this one here is, you put a negative sign on the whole thing. So that means the negative f of x in this case is you put a minus sign in front of this one, then you get negative x squared, right? So obviously the graph of that is, so negative f of x is reflection against the x-axis. So you get this one. So that's the graph of that guy. But this one here is, f of x is x squared, so f of a negative x is equal to, you have to replace the x. So see, x, whatever is here, that goes in here. So whatever's in here has to go right there. So in this case, it's a negative x squared, but this turns out to be just x squared because it's a bracket square. Negative square is also positive. So that one is actually rotation along the y-axis. So this operation here is rotation along the, or reflection against the y-axis. This operation here is reflection against the x-axis. So in this case, think about this. If you rotate this one against the y-axis, you get the same thing, right? So therefore, you get this, and that's obviously proven by this here. So negative x squared, you still get the same thing, x squared, which is the same thing as the original one. All right, and we also talked about, so this is translation, dilation, and reflection. I just talked about reflection. And dilation is you multiply the function either by like a in the inside or a on the inside or outside, okay? So if, let's say, for example, you have y equals to x squared. You may multiply this, then you get y equals to a x squared. And in this case, it's equal to ax all squared. Do you understand? So this is a on the outside, just a multiplied by x squared. This is plug ax into the x. So this ax squared. So you get a squared x squared, okay? So this either stretches or compresses the function, okay? So this one here is a horizontal compression, I would say, or horizontal dilation or horizontal compression. This one is a vertical dilation or horizontal vertical dilation or vertical compression. Okay, so for example, if you have something like, maybe I can give you an example again. So if you have like that, I drew this again. Let's suppose that this is y is equal to x squared. Then you may stretch it along the x-axis, and you get something like that. So this one is actually like something like y equals to like 4x squared. Okay, and you may make it narrower, which is like horizontal compression. So this is being compressed that way. So that all these things can be achieved by either multiplying by a on the outside or inside. Okay, I mean, yeah, you can think of going from blue to black as a horizontal compression, or you can think of it as a vertical stretch. See, so if you stretch the blue upward, then you get the the black. So we can try maybe. Oh, this one, the red one is not really 4x. The red one is like quarter x squared. The blue one, the black one can be 4x squared. So we're going to go through these later when we go through the questions, okay? And there was also, so this is dilation, and translation is simply moving the graph. So if you have f of x, you may have f of x and then plus a on the outside. You may also have like x plus a on the inside. So for example, if you have y equals to x squared, and let's suppose that y is equal to x squared plus 2. And also let's suppose we have y is equal to x plus 2 and then square. Okay, so that's plus 2 on the inside. This is plus 2 on the outside. Okay, so what does this do? Right, well, that's the original. This one is, if it's on the outside, this is a vertical, moving up or down. If it's on the inside, it's moving to the left or moving to the right. All right, so for on the outside, if it's 2, then you move up by 2. If it's negative 2, then you move down by 2. Okay, so if it's negative 2, then this is the negative 1. Now, but if you have plus, which direction do we go? We go, if it's plus, then we go to the left instead of to the right. And if it's x minus 2 squared, then we go to the right. Okay, so this is 2 here, this is minus 2 here, this is 2 here, this is minus 2 here, okay? So this is pretty much the summary of what we did last time. Now we're going to look at those questions today. Have you guys all received the worksheets? You can type your answer on the chat. Do you guys all have it with you? Okay, good. Right, so this is on, so I sent you 2 files. There's T1, which is term 1, there's a term 2, okay? So we're going to look at term 2. This is on page, like, you have to scroll down a few pages to see this page. This is chapter 3, quadratic. So this is on T2 of unit 1. So we're going to have a look at this one. So for the equation x squared minus 48 equals to 2x, x equals 2. So what that means is, what must be the x so that this side equals to this side? So obviously we can move this one to the other side. So we get x squared minus 2x minus 48 equals to 0. So whatever this is, so this is, you can let that equal to y, and y is equal to 0, which means whatever this quadratic is, I think it's definitely a smiley face quadratic instead of a frown. Why? Because this is a 1, which is positive. So they're looking for the value of x for which the y value is 0. Do you understand that? So as soon as I move this one to this side, I must have 0. It's true? So this quadratic has to equal to 0. What that means is, you see on this point, you see that this is a something 0 and then something 0. True? The y value is 0. So we need to find the x value so that the y value is 0. So obviously we can factorize this into this. So I'll give you maybe 30 seconds to try this. You have to find 2 numbers that multiplies to give negative 48 and adds to give negative 2. Well, you can type your answer here, okay, on the chat. So x plus 1. So I'll give you a sample answer. You may type your answer like this, okay? So you have to factorize it. So wait for your response. I'm not getting any answers from you. Okay, so right, so I think Yechan and David, you guys answered this. All right, so this is x. It's pretty simple, x plus so x minus 8, and then x plus 6. So you get the negative 8 times by 6 is negative 48, negative 8 plus 6 is negative 2. So therefore, the answer is 8 or negative 6. 8 or negative 6, which is B. Okay, so it's the value. What x value makes this one 0? And the answer is 8. what x value makes this one 0? The answer is -6. So the answer is this is 8 here, and this is -6. So that means sort of like the x-axis, y-axis sort of sits somewhere there. Okay, and you can also find like the y-intercept and the vertex as well, but that's not the part of this question. Okay, let's move on to question 2. It's a very easy one. So discriminant is b squared minus 4. So it's just like a baby question. Okay, it's because it's question 2. So this is a 5 squared minus 4 times a is 1 times by c is -10. So you can just put 10 here and make that plus. So that's the most effective way of doing it. Okay, so this is 25 plus 40. So 25 plus 40. So that's 65. That means when you have this equal to 0, since the discriminant is greater than 0, it's going to have 2x roots there, okay? If it was negative like this one, it wouldn't have any solution. It wouldn't have any roots. Now let's talk about number 3. So y equals to 2x squared plus 6x plus 2. The minimum value of y is, okay. So whatever this parabola is, I think it's a smiley face like that. And can you point out, like let's for example, this one is sort of like that. Okay, can you use your whiteboard yet, Chan, to figure out, to pinpoint where the minimum value is? Or maybe Chris, you can use it. You can use this. Yeah. Maybe you can go to whiteboard and just right click on the brush. Okay. Right click on the brush, then you'll see all the colors. Okay, right here. Right click on the brush on whiteboard. Chris, can you try? And Philip as well? Okay, so someone highlighted this bit here. All right. Yachan, where do you think is the... You can just use your cursor. You don't have to draw on it. You can just use your cursor and point out where the minimum point is. Right there, is it? Did you draw that or Chris did it? Okay. Okay, sure. Maybe you can get it to work. But the minimum point is right here. That's the lowest point of this parabola, isn't it? So this question is asking for what is the minimum value that's looking for the vertex. All right. So let's figure out the vertex. So using from the previous lesson, if it's in the general form, we have to use the coordinate of the vertex is given by minus b over 2a. Is it right? I hope you guys remember that. So we know that the when we look at the quadratic equation of minus b plus and minus root of the b squared minus 4ac over 2a, we know that this point here is minus b plus root delta over 2, and we know that the other point here is minus b minus root delta. So that's what this one is showing. This is the equation that helps you find the x-intercept, isn't it? Divided by 2. So if this is a minus b plus root something on 2, and this is minus b minus root something on 2, then this middle point must be minus b on 2a. Oh, this is actually 2a here. Sorry, that's 2a. So if this is that and this is that, then this must be without the delta. This is plus root delta, this is minus root delta, is that right? So that's how you find the coordinate of the vertex. Okay, let's try this. And y value is whatever you get when you plug this value into the equation. So minus b is 6, right? That's the middle value. And 2 times by a is 2 right there. So this is equal to minus 6 over 4. Minus 6 over 4. Okay, so I'm going to bring up my calculator. So once you figure out that the x coordinate is 6 on 4, so 6 on 4, by the way, is 1.5 or 3 on 2. So we can change that to 3 on 2. So it's a minus 3 on 2. So that's the x coordinate here. And we're going to plug that right into this equation to figure out the y value. Okay, so let's try that. So it's 2 times by minus 3 on 2. Is that right? 3 on 2? Yep, that's right. 3 on 2 squared plus, you can use your own calculator as well, 6 times by minus 3 on 2 plus 2. So that's equal to 2.5, or by negative 5 on 2. So that's equal to negative 5 on 2. It's negative 5 on 2. So this value here, so let's just get rid of it. So the x value here is negative 3 on 2. And we found the y value here as well. Just get rid of that. This is a negative 5 on 2. So when it says minimum value of y, are they looking for the x value or the y value? The answer is the y value. Okay, so definitely the answer is this one, so negative 2.5. That's what negative 5 on 2 is. Okay, let's now move on to question 4. It starts to become a bit challenging. Okay, so number 1, 2, 3 were just warm-up questions. Just have a look at question 4 now. I'm going to erase this one. Any question, anyone so far? Okay, I'll just continue then. Now, number 4. It says x plus 1 over x equals to 9. Find the value of x squared plus 1 over x squared. Okay. So what is the value of this? That's what they're asking. So we're going to try multiplying this by itself. So when we do square of this, of course that's a square of that. That's 81. 9 squared is 81. This one is x squared plus, you can see that you have to use this rule. A plus b squared is equal to a squared plus 2ab plus b squared. So x squared plus 2ab, so that's ab, plus b squared. That's equal to 1 on x squared, okay? So this is the clue I can give you. So you can now do the rest and figure out this value, okay? So I'll give you maybe 1 minute to try. I'm just raising my desk. You can just type your answer on the chat box. You can do your own working on a piece of paper and type your answer, or if you have any question, you can just ask. Okay? So this here can help you work out the answer for this. So they want the value for x squared plus 1 on x squared. Yachan, did you get anything? Not yet. How about David? Not yet? Okay. All right. What about Philip? Okay. I'll give you a clue. So what we want is right here. That one plus that one, right? Is that what we want? Yes. True. You just have to get rid of this guy to the other side. Then you get the answer. Is that right? So what we have is 81 is equal to x squared plus 2x over x, that's what this is, 2x over x plus 1 on x squared. Therefore, you see this is what we want, this one and this one. But you see that this one cancels out, right? So you move that to the other side, then you get 79. So this is just 2. 79 equals to 1 on x squared plus 1 on x squared. So the answer is simply 79. So that's actually easier than you thought, right? Yeah, okay, we'll move on. Okay, so let's try question 5 now. Okay, so question 5. It says the equation of axis symmetry of this graph is. So what is axis of symmetry? Equation of axis symmetry. So I'm going to do it right here. I'm going to erase this. Or maybe I can erase just the top row, the old question that we did. Yeah. You guys already have that as a PDF file, so I can just get rid of that. Okay. So when you have a quadratic equation like this, the axis of symmetry, so this line is the one that divides the parabola into two equal parts, right? I mean, two symmetrical parts. So this is the equation of at the axis of symmetry. So when you have a horizontal, so when you have like a horizontal line, that's y equals to something. For example, if that point is 3, then the equation of the straight flat line is 3, y equals 3. And if you have a vertical line, and let's say this is equal to 3, then that's equal to x equals to 3 instead of y equals to 3. So we have this equation, but let's find the vertex. Let's find the vertex for it. So we know that the vertex is x is equal to it is a set of coordinates. Of course, the vertex is given by minus b over 2a, as we saw in the previous question, you know. So you got to memorize that. And y value is, I'm just going to let that equal to y. All right, that corresponds to this value. So minus b is minus 12 over minus 12, minus 12, right? So it's negative 12, so it's a plus 12 over 2 times by a. A is equal to 2, right there. So this is equal to 12 over 4, which is equal to 3. So 3, and you have to now find the y value. Let's plug that into here. So this is equal to 2 times by 3 squared minus 12 times by 3 plus 17. So that's equal to 9 times 2, which is equal to 18, minus 36, plus 17. So this and this is 35. Minus 36 is equal to minus 1. So it's minus 1. So whatever this equation is, we know that it's a smiley face, of course, because it's positive. And you got 3 and minus 1. So 3 minus 1 right there. And it's sort of like that, you know. So we haven't actually found the x-intercept. We know that it's going to go sort of like this and then go that way. And probably it's going to go through like that, okay? But we don't know if it's going to have 2 positive roots or 1 positive root, and it may actually be flat like that and then go through. It may look like that, you know. We don't know, but we're not interested in that, you know. We are only interested in the axis of symmetry. So this one here will be x equals something. I want you to think whether, so by the way, this coordinate here, we found it is equal to 3 minus 1. So I want you to tell me if the answer is equal to x equals to 3 or x is equal to minus 1. Okay, so pick your choice and type your answer, okay? Like that. Or like that. Okay, so Chris has picked an answer. David picked an answer. Good. Yachan, everyone's saying 3. Okay, so you have to say x is equal to 3. You can't just say 3. Okay, because 3 is nothing. They're looking for equation. So it has to be x equals to 3. So it's actually D here. Okay, so that's what. So all this was really asking was, what is the x coordinate of the vertex, which is 3. And that's pretty much the same thing as the equation of the axis of symmetry. Now we're going to move on to question 6, of course. All right, I'm going to erase this. Any question, anyone? All good? All right. This one here is, okay, equation of this. This is also quadratic equation in general form. So y equals to 4x squared plus mx plus 1 equals 0. Okay, I also always prefer to write y on the end. So this equation will have only one real root when the value of m is. Okay, so this one, whatever this is going to have only one real root. And I know that it's actually like this instead of upside down like that because this is 4, which is positive, right? So I can just get rid of these two. So this one will have, so depending on the value of m, it may look like this, it may look like that without any x-intercept, it may look like that with the 2 intercepts there. But we want to choose value of m so that this just has one x-intercept or one real root. That's what it means. So that means we want the b squared minus 4ac, which is the discriminant, to be what? To be greater than 0 or equal to 0 or less than 0. Pick your choice. Yeah, everyone's saying equal to 0. Good. So we just have to write, all right, m squared, which is b squared. M squared minus 4 times a is 4 and c is 1, like that. So we want this to be equal to 0. So this is m squared minus 16 is equal to 0. And you have to find the value of m. You have to solve this. Okay, you need to solve this. And there are several ways of doing it. Okay, I want you to write down your answer. What must be m? What should be m? And the answer, you can actually pick your choice here. So everyone is saying 4, but the answer is 4 or minus 4. You guys see that? Because negative 4 squared minus 16 is also 0. Do you see that? So there are several ways of doing it. First, you can just move this one to the other side. M squared is 16, and you take square root. Whenever you take square root, you put plus and minus. Then you get plus and minus 4. Make sense? And you can also do factorization method. Factorization is, this is a m minus 4, m plus 4. So that's equal to 0. So where do I get that from? You should know a squared minus b squared. Difference of two perfect squares are the sum of those two and the difference of those two. Okay? So this is a squared minus 16 is 4 squared. So this is a m plus 4, m minus 4. Or you can write m minus 4, m plus 4. So that's equal to 0. So to solve this, of course, m must be 4 or minus 4. So that's another way you can do it. Another way, of course, you can do is use the quadratic formula. So m equals to, the quadratic formula is, memorize this. This is going to show up again and again in year 11 and year 12 maths. Minus b plus and minus b squared minus 4ac over 2a. So obviously this is another quadratic equation. So we can replace the x by m, but this is like the longest way to do it. You got m squared plus nothing m, and this was a minus 16, was it? So a is 1, b is 0, c equals to minus 16. So you can try that as well. Plug that all in here, but that's going to take a long time. And obviously in this case, you know, m squared minus 16 equals 0 is such a simple thing. You don't have to treat this as if it's a general form like this one. We use this equation pretty much only when you have equation in this form with all of this, all these three terms in there. This one is just having just two terms, right? So you can think of that as m squared as x squared. So those two. And you got negative 16 is the same as c in this case. And b is 0. Okay? Well, let's just try using this just for that equation, this one here. So what is b? b is actually 0. See, the b, this term is not here. So it's 0. And you got plus and minus root. b is 0 as well. So this is 0, 0. And you got negative 4 times by a. a is actually, this is a 1m squared. So this is 1. And c is equal to minus 16, you know? So you can make that plus 16 over 2 times by 1. And what you get is plus and minus root of, 16 times by 4. How much is that? That's a 64 over 2. And this is a plus and minus root of 64 is 8, right? Over 2. So what's 8 divided by 2? That's 4. So you get plus and minus 4 again, as before. So that's another way, but it takes way too much time, So the answer is E, which is plus and minus 4. We're going to move on to this one. I'm just going to leave that as homework to you. You just have to expand it out and collect the like terms. And I think you can do that, right? 8 as well, I'll just leave that to you. X squared minus 5x minus 14 equals 0. What are the solutions? You can maybe factorize, and you get maybe 7 and 2, negative 7 or 2, negative 7 or 2, or negative 2 and 7, I don't know. So I'm just going to leave that as your homework. The solution to this one are Well, obviously, you don't have to use the quadratic formula to solve this one. So there are two ways again. You can just solve for x, so put the 1 on the other side like this, and then you get x squared is equal to 1 on 4, is that right? And then take square root, then x is equal to plus and minus root of 1 on 4. So root of 1 is 1, root of 4 is 2. So this is a plus and minus half. So the answer is C. Another way is you can factorize this one into two things. So I'm going to leave that to you now to try. I'll give you 1 minute. Do it now. So you have to factorize this using this equation, a squared. I wrote it down here before. Where is it? It's gone. Yeah, a squared minus b squared is equal to a plus b, a minus b, right? So if you have 4x squared minus 1, what is that? Okay. So write your answer like this, Something like that, I just wrote down a wrong answer for you, but you guys can think about it. Anyone? I'm not getting any response. Okay. All right, Yechan, you nearly got it. So Yechan said 4 plus 1, 4 minus 1. But the answer is actually, got to put x here. But this, instead of 4, you have to write 2. So Chris, you got it right. Excellent, very good. So 2x plus 1, 2x minus 1. So you can see that this one times this one is 4x squared, like this one, 4x squared. 1 times minus 1 is negative 1, is it right? So you factorize this into this equals 0, then obviously, what are the values of x that makes this bracket 0? The answer is x must be negative half for this one, and x can be just half, because half times 2 is 1, 1 minus 1 is 0. So you get that. So you can try either the factorization method, or you can just solve it directly, okay? Let's go through question 10 here. It says the x-coordinates of the points of intersection of the parabola, this one and this one, are. So you have a parabola and you have a straight line. That one is a straight line, this one, and that's a parabola. And they want you to find the coordinates, the x values, x coordinates of these 2 points. So this could be like negative 1, like 2 and negative 1. So this is like 2 something, if this is correct answer. And this would be like negative 1 something. So how do we find the 2 points that are intersected by the 2 things, this one and this one? Let's actually, I'm just going to show you the answer on a graph paper. So let's have a look. So this is x squared, have a look, minus 2x plus 3, was it? Just let's have a look again. Well, that's a minus 3. And the second equation was x plus 1. So you got 2 things right there. So let's have a look at this. So this one looks like it's 4, 5. And this is negative 1, 0. So I'm going to copy and paste this one. into our stuff right here. Okay. So the question was, what are the x coordinates of the points of intersection? They wrote point or points because that could be more than one point. Obviously, in this case, is points. So you got this one right here and this one right here. So what are the answer? They're only looking for the x coordinates. I want you to type your answer. X coordinates of the points of intersection. What's your answer? The answer is 4. You can see that this point right here is 4, 5. Is that right? 4, 5. This one here is -1, 0. So they're only looking for this and this. So -1 and 4 is correct. -1 and 4. Okay. So that's how you do it. You can just but I mean, you can use the graphics calculator to do it. But how do we do this algebraically? Have a look. So we just sort of cheated, by using the graphics calculator. So you got this one here, and you have this one here. So we notice that when they intersect, so at this point and at this point, the y values, the y value of this one and the y value of this one, they are the same. And of course, the x value here and x value here will be the same because they will share the same point. So anyway, the y equals to this and y equals to that. So why not let y equal y? So let this y equal this y. So that means x squared minus 3x minus 3 equals to x plus 1. Just let that equal to that. So this is a quadratic equation equals to this linear function. But if you move it onto the other side, you actually get a whole different quadratic equation. So this quadratic equation is definitely different from this one, isn't it? It's definitely different. I'm going to solve this quadratic equation, and something magical happens, So I can factorize this one as -4 and +1. Is that right? So therefore, x is equal to 4 or -1. Look at that. What's that? -4, 4 and -1. See? So if we actually plug that into, if I plug 4 in here, I get 5. If I plug in 4 here, I get 16 minus 8, which is 8, minus 3, which is also 5. Okay? So all I did was equate those two equations, put everything on one side, and make it into a brand new quadratic equation, and solve that. And in this case, we could do it by just factorizing. All right? We're going to try, so I'm going to leave question 11 to you, and 12 as well. And 13, we're going to try, and we're going to try a free response question. Maybe we can try. Yep, this one here. I'm going to copy and paste. And then after that, we're going to try a difficult problem. So this one is saying there is a parabola, 1, 6. So 1, 6 is somewhere there. And passes through -1, 8. -1, sort of 8 there. So this turning point is the vertex. So it has to go like this. So in this case, we can use, because we're given the vertex, we can use the vertex form. The vertex form is this one. I wrote it in the summary. Okay, so we got 3 forms of quadratic equation. One is this one, this one, this one. Depending on what you're given, you can use this one, this one, this one, anything. So, but in this case, oh, what did I wrote y-intercept form? This has to be the vertex form. So they gave us the turning point, which is 1 and 6. So you can write, we don't know what A is, but the vertex is 1, so put -1 here. So it's the value that makes this bracket 0, and the answer is 1. So because it's 1, to put -1. We talked about that last time. And you take that value as it is. That's no problem there at all. So whatever the quadratic is, it's going to look like that. And obviously the value of A can make this parabola a bit steeper, like this, which still goes through the same point, 1, 6. You can make it a bit sort of a wider, like that, depending on the value of A. But A value is such that it goes through this point right here. And that point is not a special point. It's just a parabola that goes through that point there. It's not that special at all. It's 1, 8. So we're going to plug that into the x value and y value. Then that will just leave us with A, right? So this is 8 equals to, A equals to, I don't know, that's what we want to find out. And x is -1 and -1 square plus 6. So this is equal to 8. And this is a -2 square, which is 4. So this is 4a plus 6 there. So you divide, minus 6 there, you get 2. And a is equal to 214, which is equal to 1/2. So the whole equation now, so the answer is y equals to 1/2 x minus 1 square plus 6. So that's the answer. We're going to have a look at question 2 now. Says a parabola x has an intercept of 2 and 7 and passes through this point. So I'm going to draw this. 2 and 7. So 2, 7. And also passes through 3, 6. 3 is somewhere there. And 6 is somewhere there. Is that right? So I think the parabola has to sort of look like that to make this point, to go through all these 3 points. So because they gave us the 2 x-intercepts, we can just go up and look at the second form of quadratic equation of parabola, and it's this one right here. I hope everyone can follow this so far. We have been just repeating, the same concept over and over and over, and that I think is necessary at this stage. So, if you just repeat the same concept over and over and over, it will just stick to your mind, okay? So that's how you study. At first, you may think it's difficult, but the second time you do it, it's doable. Third time you do it, it gets really, really easy, and everything makes sense. So y equals to a, this is the form, and this goes through 2 here, 7 there. So that means this must be x minus 2, not x plus 2. So this is x minus 2, x minus 7, and still we have to find a value, okay? The reason is there are myriads of parabolas that go through 2 and 7, so I'm going to draw a couple more. So there is some parabola that may look like that. It's a bit lower and wider, like this. There could be an even narrower parabola like this. That all go through 2 and 7. See? But this particular one, that's why they provide not only these two pieces of information, but they also provide this information that it goes through a particular point that sort of fixes the parabola. Okay, so you're not free to have this or that or this. You have to by this. That's why this third information allows you to find the value of a. Okay. So let's plug in 3 and 6. This is what we did before. They provided the two information here. So 1, 2. And you have this third information. So y equals to 6. A is the unknown. You know, x is equal to 3. So this is a 3 minus 2. And this is 3 minus 7. And can you guys actually tell me if a is positive, like this? I'm typing. A is negative. So which one? Just by looking at the equation right here. Can you guys tell me? So it's definitely negative, isn't it? Because it's upside down. So we're going to see that actually. We're going to verify that a actually is negative. So this is a 6 here, a here, and this is a 1 times by minus 4. So 6 equals to minus 4a. And obviously a is equal to 6 on negative 4. That gives us negative 3 on 2. So the final equation of this is y is equal to negative 3 on 2, x minus 2, and x minus 7. Okay, we're going to move on to, so that's parabola. So I'll leave you guys to do the rest. And maybe you can try this one as well. But this one is a bit difficult. So I want you guys to pay very close attention to this one. A lot of people get confused about this one. Oops, where's the... Okay. So here's a question where the quadratic equation is in the general form. So you have x squared px plus 2p. Can you type what a is? A equals 1, and b and c are. Just type your answer. So what is value of b? And what is the value of c? This is in the general form, I think. This is a x squared plus b x plus c. So obviously the a value is 1 right there. What is b? B is this one right here. Okay. So Chris is saying that b is px, but very close. B is actually just p, because there's an x there, right? So b is the coefficient of x. A is the coefficient of x squared. So, you know, a is equal to 1, b is equal to p, and c is equal to not 2, but this whole thing here. So that doesn't have any x in it, right? So we have x squared, x, and it's just c. So c is the one that doesn't have any x, and this doesn't have any x in it, right? So c is equal to 2p, and b is equal to p. So it says find the discriminant. So delta is equal to b squared minus 4ac, right? So I want you to use this and write down the delta, okay? So I'll give you maybe a few minutes to try this, just 1 minute maybe. So this will be, yeah, it's your chance to do it. B squared, b is p there, so this must be p squared, right? Minus etc., etc. P squared minus 8p, that's right. That's good, that's good, very good. So 4 times 1 times by c, c is equal to 2p. So this is equal to p squared minus 8p. Because this is p squared and 8p, we can actually write that as p, you can factorize p easily, and then p minus 8. So again, this is the best form of the discriminant. Okay, so find the values of p. We're going to try d first, okay? Find the value of p for which this quadratic equation has just one solution, or one root, or one x-intercept. All right? That means the discriminant has to be greater than 0, equal to 0, less than 0. The answer is equal to 0, right? So it has to equal to 0. But we know that the delta is p bracket p minus 8. So p minus 8 is equal to 0. That means p has to either equal 0 or 8. Okay? So let's have a look. What would happen if p is equal to 0? Then this equation will turn into, I'm just going to put y there. So y equals to, this is 0, this is 0, so you're going to get just x squared. David, what's your question? P less than 8? What do you mean by that? You're the wrong question. Okay. It's all good? All right. So y is equal to x squared is what you get when p equals to 0. So, and definitely you can see that this one has just one solution, doesn't it? It just touches the x-axis just once. Let's consider p equals to 8 here. So depending on the value of p, this parabola changes. So we're going to get y equals to x squared plus, this will be 8x, because this is 8, you know. This is 8x plus, this is 8 now, so 16. So what does that look like? Let's have a look. So that gives you x squared plus 8x plus 16. And take a look at the blue guy. This one also has one x-intercept. So that definitely satisfies this condition here. So find the value of p for which this quadratic equation has one solution. So we found that this one was kind of here, with this value being 4, negative 4. Okay. Now we're going to actually also try this question here. So what are the values of p for which there are two solutions? So here's the so we know that the delta, which is equal to p bracket p minus 8, has to be greater than 0. Is that right? So before we go on, I just want to explain a few things here. Just going to get rid of that. Okay, so the original equation is y equals to x squared plus px plus 2p. And then from that, we constructed the delta. Delta equals to the p squared minus 8p, which can be factorized into p minus 8. So what we get is actually, within the quadratic, we get another quadratic. So This is y and this is x. And you can get all sorts of parabolas depending on the value of p. Okay, is that correct? Now we have another quadratic system, and in this case the y-axis is the delta, and the x-axis is p. I hope that makes sense to you. Now, whereas this parabola changes its position, like previously, when p is equal to 0, we found this one. When p was 8, we found this one. You can see that right here. Can you see this? So this was that one, and we have just x squared, which is this one. So depending on the value of p, we see them like changing, shifting all the time. But this is quadratic here, this is like y and this is like x. And this one, there's only a fixed quadratic equation here for this one. So this is it goes through 0 and it goes through 8. And the parabola is a smiley face. So this is the graph of delta versus p. So this is 8 and this is 0. So from this one, for d, because the delta has to be 0, we found the value of p equals 0 here and p equals 8 here, as you can see. For those two values, see the delta is 0. Do you see that? Because this is the y value. The y value is 0. That's why delta is 0. So that's the value 0, 8 that satisfies this condition here. But now we want the delta, because we want to have two values. We want this to go something like that. We want this to have like two values like this. Okay? So that means the delta has to be greater than 0. But delta is greater than 0, so the delta is greater than 0 here and here. You see that? And it's 0 here and here. And delta is less than 0 here. See that? So for this one here, because there are no solutions, we want the delta to be less than 0. For this one, we want the delta to be greater than 0. Okay? And here we wanted the delta to be equal to 0. So I want you to try these two for yourself. If the delta has to be greater than 0, what must be the value of p? And I'll give you a clue, it's an inequality. So your answer will be like, David said p less than 8, but that's, yep. So it will look something like that, but that's not the correct answer. Okay? Because less than 8, you can see that it's actually negative. So p less than 8 is actually closer to the answer here. All right? So this is a very difficult problem for everyone. But again, if you go through this again, or this recording is going to be available on YouTube. If you find it confusing, you can go through it again. Maybe if you go through this again, like in June or July, or maybe at the end of this year, it will make more sense. Okay, so repetition is always the key to a better understanding. I'll give you a clue. I think p has to be greater than 8. If p is greater than 8, like for example here, then the delta is positive. See? You see? What's another answer? You can put or. We're looking for the blue. Blue is where it's positive. P has to be less than how much? So all this is where P is less than 0. That's good, Chris. Well done. So these are the answers. We're going to test it later, okay? Find the values of P for which there are no solutions. That's less than 0. That's right there. In this case, you don't have to do this like in two separate fragments. You can do this. P is in between something. The answer is obviously 0 and 8. Okay. So I'm going to put this on the test, okay? Put this to a test. So we found the graph. We found this graph, how this graph becomes, what this graph becomes when P is equal to 0 and 8. And those are given by those two here, this and this. Now I want you to just choose any value between 0 and 8. First person to type. I'm going to pick that number, okay? Choose any number between 0 and 8. All right, 3. Let's go for 3. So let's suppose that P is equal to 3. Then it's right here. So it's not supposed to have any solution. Is that right? So I'm going to plug in 3 here. So then y equals to x squared plus 3x plus, and this will be 6, right? So I'm going to plug that into the calculator. So let's have a look. X squared plus 3x plus 6. And look at that. Does this have any x-intercept? It does not, right? Maybe there is a way to make this one into P. And this was a 2P, was it? That's right. So add a slider. We can change that to, so have a look. This is when P equals to 1. As I vary this, the parabola changes, right? Look at that. So when P becomes 0, that was when it had one solution. And that was also 8, right? If I move it to about 8, you can see that the parabola is coming down. Like that. And that just has one solution, right? Just one solution, or one x-intercept. And what happened between 0 and 8? So 0 was like here. One solution, one solution. Between 0 and 8, no solution, right? No solution, no solution, no solution. True? This is very, very interesting. So you can see, between 0 and 8, no solution. But if P is less than 0, let's go for less than 0. So have a look. If we go for less than 0, then it starts to have two solutions. Okay, you can see 2 solution, 2 solution, 2 solution, and parabola gets very, very big. Yeah, 2 solution. And also greater than 8. What happens if it's greater than 8? Then it starts to have also 2 solutions. Right? So that's all about this question right here. Okay? Hope this was fun. I think now we should move on to polynomials. Any question about this? So if you understand this one, then that means you're pretty smart. Now, I'm going to so this chapter here, chapter 6, is about functions and relations and transformation. We talked about like dilation and translation and reflection and things like that, right? So I don't think we have time for this one today. We're going to go through polynomials. Okay. Polynomials. Okay, let's have a look. So here's a polynomial, and this is exactly divisible by x plus 1. What is the value of a? So we have to use the factor theorem. Factor theorem says that if you have a p of alpha equals 0, then x minus alpha is a factor. What this one is saying is that you got some polynomial ax3 plus 2x squared plus 5. So that's the polynomial. But they say this is exactly divisible by x plus 1, which means this is a factor. That's a factor. That means if I plug in -1 here, -1, then it'll equal to 0. Is that right? So let's plug in -1, -1. So this will be -1 to the power of 3 is, what's -1 times -1 times -1? That's -1. So this is negative a. -1 squared is 1, so this is 2. This is 2 times by 1 plus 5. So this is equal to negative a plus, this is 7, isn't it? 7 equals 0, so 7 equals to a. So the answer is 7. So we're going to put this to a test. So because the polynomial is now defined as 7x3 plus 2x squared plus 5, we can actually divide this just to check, you know, if this is really exactly divisible by x plus 1. Then I'm going to put have to multiply this by 7x squared in order to match the leading terms. Then I get this times by this is 7x3. This times by this is 7x. And then you subtract, and this is negative 5x plus 5. This one comes down. And you multiply this by minus 5 to get negative 5x. And this by this is minus 5. Hold on, it's plus 5. It's a bit strange. Hold on. It's not working. Did I make any mistake here? Negative a plus 2 plus 5. I have to plug in -1, that's right. And this is 7. And a equals to 7. And then this becomes a 7x3 plus 2x squared plus 5. Oh, hold on. I made a mistake. So when you're doing long division, you have to put a space in between those two. So this is a 7x cubed. That's x cubed. This is x squared. And you put a 0 in there. And then 5. So this is a constant x squared, x3. Okay. So if there's a term missing, just put a placeholder like 0. Okay, like this one. You know, there's no x. So I'm gonna do this. This was x squared and this is x, so that's why they're not addable. Right? I made a mistake. Sorry, it's a very stupid mistake. So what you have to do is this times by this is this. This times by this is 7x squared. You actually get it right. This times by this is this, and this times this was actually 7x squared. So it is actually right. And this is all 0, 0, and you subtract this from this. Then you get negative 5x squared. And this is, 5 comes down. Now multiply this by negative 5x. Then you can match this number, right? Negative 5x squared. And this times by this is negative 5x. Of course, that's different from this one. And you subtract again, this and this are gone, and you get 0 minus this one is positive 5x plus 5. And then finally, if you multiply this by 5, then you get 5. This times by this is 5x. This times by this is 5. And you subtract, you get remainder of 0. That means this is exactly divisible when a was 7. When this number was 7, this was exactly divisible by this one. So we can rewrite this thing, this polynomial, as x plus 1, the divisor, and the quotient. I just want to ask David if you've done something like this in class at Canberra Boys Grammar. You finished already? Okay, good. So pretty good with this topic, right? Okay. All right, let's go through this one. So possible equation for this graph is, so what is the equation of this graph? So definitely this is cubic. So it has to go through x, that goes through -7, so it must be x plus 7. This is a -2, so that must be x plus 2. And this is 5 here, so it must be x plus 5. But always have to put an a there, because there could be all kinds of different equations, polynomials that can go through -7, -2, 5. Okay, but so they gave you these three information that so you can work this one out. And obviously they are all just passing through this. Okay, no bouncing off. So this is all power 1, 1, 1, no square, no power of 3. And you can work out a using this last information there. It's -5. So whatever this parabola is, it goes through 0, -5. So that means y is -5 and x is equal to 0. So this is a, 7, that's 2, that's 5. Is it right? -5. That was -5. Then you can actually cancel the -5s. So that means it's a 1 equals to a. This is 14. So a is equal to 1 on 14. So the answer is one of those. Not this one. +7, +2, -5. That's right. So C is the right answer. Okay, let's try number 3. What is the remainder when this is divided by this? Of course, you can do the long division, which is the longer way. You can divide that by 2x minus 1 and do all the quotient and then find the remainder. It cannot be 0 because those are the choices: 1, half, -half, -4, -1/4. This is the longer way, but what is the shorter way? We know that using the factor theorem, remainder theorem, there's a remainder theorem. If you plug in something and you get r, then r is the remainder when the polynomial is divided by x minus alpha. Okay? So they are saying this is divided by this, and what is the remainder? All you have to do is plug in some number into this. Then you get the answer. Okay? So I want you to tell me what value you have to plug it in here to get the remainder. So once you plug that in, then you get the answer. I want you to tell me, type the answer. Okay? For example, when the polynomial is divided by x plus 1, to find the remainder, we just plug -1 into the polynomial, and we'll get the r. David, can you tell me what you should plug in here? Yechan already gave the answer. It's half. So it's the value that makes this thing 0, isn't it? Yeah. So if we plug in half there, let's plug it in. So half is the one that makes this thing 0. So it's 2 times by, this is half here, so 0.5 to the power of 3 minus 2 times by 0.5 square plus 10 times by 0.5, and a minus 5. So the answer is negative 0.25, which is actually negative quarter. So the answer is E. So I'm going to do this long way to actually verify that this is indeed correct. It sounds like, it sounds too easy, but this is actually correct. So we're going to try the long division. So this multiplied by what is 2x3? The answer is x squared. Multiply by x squared, then you get 2x3. This times by this is negative x squared. So just subtract. Then this minus this, then you got to add this one. So it's a negative x squared. And all these things come down. 10x minus 0, negative 5 minus 0. So you get that. Now, this times by what is this? The answer is negative half. So negative there because it became negative. And then you have to, what is it? Yeah, negative half, because 2 times y half is 1, and multiply by x. So this by this is this. Okay, you can check that later yourself. And this times by this is positive half. Positive, I'm going to just write 0.5 x, okay? And subtract. And this are gone, so this minus this is 9.5 x minus 5. I'm going to now multiply, so I'm going to match this one. So it gets a bit complicated, but so I'm just going to use maybe my calculator. So 9.5 divided by 2, so it's a 4.75. It's actually 19 on 4. So if I multiply this by 19 on 4, then 2 times by 19 on 4 is actually 9.5. Okay, so 2 times by, so times this by 2 is actually 19 on 2, which is actually equal to 9.5. So there's a bit of a fractions going on. So this by this, get that, 9.5. And this by this, of course, is a 19 on 4. And I'm going to subtract. So this and this are gone, of course. And just let's put it into calculator. So it's a minus 5 minus 19 on 4. Then you get negative 0.25 indeed, which is this one. So the remainder is negative 0.25. Okay, so it's working. Here, this is very, very easy. If this is divided by this, what is the remainder? Plug in 1, 1, 1 there. Then you get 2 plus 3 minus 2. The answer is 0. So the remainder is 0. That means this one is a factor of that. I hope that makes sense. We're going to move on to the next question. So these are all easy questions. I think number 5 is also very easy. The answer is negative 1, negative half, 3. Negative 1, negative half, 3. So the answer is E. This one is a cubic equation, and this is a bit of application to the, we can actually try this ourselves. We can actually apply the graph translation knowledge to do this one. The question is, what is the equation of that? I'll just give you a clue. The basic function we use to figure this one out, for this one to figure this one out, is y is equal to x to the power of 3. Okay. Just as you know what the graph is for y is equal to x squared, like that, and we were able to calculate like the translation of this, like moving to the right, left, up or down, reflection against the x-axis, y-axis, all that. We'll start from here. And I believe this has gone to the left and then up. Do you see that? This is a translation to the left and up. So if we apply that here, I think y has to equal to something x plus something to the power of 3, of course. You have to change the x. That's going to move it to the left or right. Okay. And then you have to add something to make it go up. Is that right? I want you to write down your answer. So what is the graph that represents this graph shifting to the left by 1, up by 2? So write your answer. This is a 1, 2. So go like that. So that's your answer should be like this, like x plus. David, what do you mean by A? Oh, you want to know if this is that one? Okay. Yeah. Okay. So this is definitely plus 1. That's right. So it's plus 1 because it's moving to the left. So it's plus 1. And because moving up, that's plus 2. Yeah. But obviously, there are all kinds of graphs that can go through that. So it can be like this, or it could be a bit steeper. It's all the same stuff. Could be like that. All kinds of things. So that's why we have to put an A there at the front. So definitely not going to be this or this or this or this because it's plus 1, plus 4. So definitely it's the only choice that is A, but we can actually figure it out A ourselves. So this is one piece of information. Another piece of information that we provided is this one and this one. And I think you can use either. Okay, you can really use either of them. So I'm going to choose maybe 4. So that means x equals to 0. This is 0, 4. This one is minus 2, 0. So we can try 4 here, 0 here. Then it's a 1. Then you get 4 equals to just a plus 2. You get 2 equals to a. Right? Then you get a equals to 2. You can also use this piece of information. You get y equals to 0, x equals to minus 2. So y equals 0, a, this is minus 2. So minus 2 plus 1 is minus 1. Like that. And we can see negative 1 to the power of 3 is still negative 1. Negative 1 times by a is negative a. So you get a equals to 2. There you go. So you can try that. Okay. Very easily. Now have a look at this one. This is also a very, very important one to practice what we learned before. Copy that and paste it right here. All right. What is the formula for this one? So obviously it goes through that one and it goes through that one. So it's x minus b and x minus a. So it's something like that, y equals to. All right, well, I want you to, have a look at this and figure it out yourself. I'll give you maybe 30 seconds. Just make a choice. What is it? Is it x minus b square, x minus a, or x minus a square, x minus b? The clue is right here. See, at b, it bounces off. It bounces off. Right? Okay, so David chose A. Yechan also chose A. But everyone's choosing A, but I think the answer is D. The answer is D. So obviously, because it's bouncing off, this is square, and obviously this is cubic. You know, if you think about it like that, it can maximum go through 1, 2, 3, right? So this is definitely a cubic one. So this is a x minus b squared because it's bouncing off, because this is a x minus a. This is just going through. We talked about this now, just about like 2 hours ago. However, it could be that, or it could be that, you know? You have two choices. So this is when a is positive, and this is when a is negative. True? But think about this. Your choice is a, but if you actually expand this one out, think about this. The first one is x squared minus 2bx plus, 2bx minus like b plus b squared, and then times by x minus a, and you expand this one out again. This times by this, and this times by this, and this times by this, and this times by this, all of that. Then you're going to get x to the power of 3, etc., 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 and you get 1. This is 1x3. That means a is positive. That means it's like that. Okay? But it's like that. So, in order to get this curve, all you have to do is place a minus sign at the front. But you see that the only thing that with a minus sign is like that one there. But that one cannot be the answer because it says x plus b. It must be x minus b and x minus a. So some of you might be confused about why this one is x minus b and x minus a. For example, this is positive value and this is negative value, right? When we had, for example, like something like this, and this is like -1, for example, let's say this is 2, then don't we do like x minus 2 and an x plus 1, right? And this is square. I'm going to maybe write it the other way around. X plus 1 square. You see, for this one, we would do x minus 2. So this is a plus here, this is minus here, right? But y, when it's like b here, which is negative, and this is a here, why do we still do x minus b, x minus a? Why is that both negative? Does that confuse you? You can type yes or no. By the way, the answer is, so A is very close to the answer, okay? Does that confuse you? Yeah, okay. So Chris said it's confusing. Anybody else? Not confusing? Still thinking about it? Okay. So David said no, right? How about Philip? Okay, so it doesn't matter. You can see that the b, even though it's a negative value, so the value b itself contains a negative value. So b itself is -1. So if you actually use this form, then this would become x minus -1 squared. So that turns into x plus 1, doesn't it? So it is working. In this case, if a is equal to 2, then you can just plug in 2 here, then you get x minus 2, which is consistent with this one. So when these are in symbols, when they are in symbols like a or b, which may contain negative sign in them, you just have to do x minus b, x minus a. You don't have to do plus for them at all, even though they're negative. Okay, just stick to the x minus b, always just negative. Okay, you know how when we did the x-intercept form, we did x and then x minus alpha. x minus beta. It's always minus sign, right? So if this is confusing, I can just type this in a few words, okay? If like pronumerals are used, just use negative sign, okay? So yeah, that's all I can say. I'll stick to that, all right? So this is b, this is a. We don't care if they're positive or negative. It's just x minus b, x minus a. And that's square because that bounces off, okay? Now, but to make this one go that way, I told you that you have to use, hold on, you have to use the minus sign, true? But this minus sign can go in there. So put that into this. Then it can become, a can come to the front because it's negative. It can become plus, and that can become negative. So it's x there. So that's the same answer as D. So negative sign is hidden there. Do you see? So the answer is D. I hope that makes sense to everyone. Let's try one more problem. Okay. Yep, try this one, question 10 yourself. You have to find the equation for this one. I can give you a clue. The clue is this one is both pointing upward there. That's upward there as well. It's go through this one, bounces off this one, and go through this one. So Chris is the first person to pick the answer. She said, I'm not going to reveal his answer. He is right. So he said B. B is the right answer. Well done. Because it goes through -6, it must be x plus 6. And because it bounces off that one, it's a x plus 3 squared. And it goes through that one, so it's a x minus 3. And the overall power of this one is, of course, 1, 2, 1. So this is 4. It's a quadratic equation. So, and it's positive. That's why it's both pointing to infinity. So the answer is B for that. Well done. All right. We can now try, we can also try this question up here. We can try these two. Okay, firstly, there are two unknowns. So they say this equals 0 at x equals 1 and x equals -3. That means this one is divisible by x minus 1. So this polynomial, I'm going to write it here, polynomial is equal to x to the power of 3 plus ax squared plus bx minus 9. And this definitely is divisible by x minus 1 and x plus 3. That's why when you plug in x equals 1, x equals -3, this whole thing equals to 0. So if we plug in 1 here, so p of 1, 0. P of -3 equals 0. So let's plug in 1 here, 1, 1, 1. Then you get 1 plus a plus b minus 9 equals 0. And plug in -3 there, then you get -12 27. That's what negative 3 to the power of 3 is. And negative 3 squared is 9, so that's positive 9a. That's a negative 3b minus 9 equals 0. So if we rearrange this, we get a plus b equals to, put 9 to the other side, 1 on the other side, that's equal to 8. And this one here is 9a minus 3b, and that's equal to, this is negative 36. If you put the other side, you get positive 36. So what is this question about? You have this polynomial, but this polynomial is incomplete, isn't it? So you have this polynomial, but the coefficient of x squared is unknown, coefficient of x is also unknown. But you got this two pieces of information, that's a factor, that's a factor. So plug in 1, then you get this. Plug in 3, then you get this, equals 0. So you get two equations and two unknowns. So this is a simultaneous equation, isn't it? Simultaneous equation. So if you multiply this top equation by 3, then you get 3a plus 3b equals to 24. And this one here is 9a minus 3b equals 36. And if you add them up, then the b cancels out. So this will be 12a. This is equal to 60. So a then equals to 5. So this must be 5. Now we can figure out b as well, because we found a as 5, b must be 3. Okay, so b is equal to 3 there. Any question, guys, for this one? If not, I'll move on. Let's try this one, question 9. What the graph of this cubic equation? Okay, usually the cubic equation, so if you have y is equal to x to the power of 3, we talked about that. If you just have that one term, it will look like that. But, you know, this side can go up and this side can go down. And for something like y is equal to x plus 1, like x plus 2, like x plus 3, can, you know, sort of look like that, you know? So that's another cubic. So it can look like that, or it can look like, you know, it can come down and go up and sort of like that, you know? So there are different shapes of cubic equation, but you have to just figure out the answer based on this equation right here. I want you to maybe think about, this is the last question, okay? So I want you to think about this and pick your choice. Obviously, there are two, you can just eliminate two answers, two choices. What are they? You can make your choice. I'll just tell you straight away, E cannot be the answer. You can also eliminate another answer. D, that's right. You can get rid of D. The reason is, when x is equal to 0, y equals to 2. So that's the intercept there. So this is going through 0, 0, right? But this is going through 2, 2, and 2. See? So how do we work this one out? This is a cubic equation. So all these choices only have one x-intercept. Is that right? One x-intercept. And we can, so maybe I'll leave this one as an exercise to you. I want you to think about this. And if you get stuck, you can just use the graphics calculator, like right here. Okay, so I'll leave that as homework and get back to me if you get stuck with this one. So David, by the way, if you have Facebook, we are all on the what's called we have a Facebook group chat, year 11 BSSS. So you can just find me on Facebook. So this is my name. So find me on Facebook, and you can just friend me, and I'll just add it to the year 11 BSSS Facebook chat. Okay, so we'll call it a day, guys, and I'll see you next week. Have fun.